Opportunity again to hear the comment, and I've heard it so many times, but I did a presentation yesterday with Scott Perry from DEP that's responsible for this whole side of DEP, the oil and gas side. One of the things that he said, and so many others have said, and certainly our geologists at the university and EPA is claiming the same thing, is are there fluids, these frac fluids, as they're pumped down hole, and they're very deep, we're talking about somewhere between 5,000 and 8,000 feet, are they migrating back to the surface from depth, or is there potential for that to occur out there? So I'd like to explain that just a little further, maybe, if I could. So this is an example. So if this is a black shale, and this actually has some natural fractures in it, has a limestone under it, it actually has a limestone above it that's up in here. So you have this trapped zone of black shale. And that would be similar to what the Marcellus is, okay? The Marcellus has a limestone under it that's very dense, a limestone above it that's very dense, and that shale layer that we're calling the Marcellus in between. What companies are trying to do is bore down and bore horizontally into it, perpendicular to those natural fractures, and then send down under pressure that water, the proppant, the chemicals to fracture that open, or essentially fail the shale, as they like to call it in the industry, trying to fail the shale. So they're creating small hair-like fractures in there, and that's why the gas is going to be able to flow back out. What they're trying not to do is they're trying not to break the limestone under it or the limestone above it. And if they were to break one of those two zones, then what would happen is the pressure that they're pumping down hole that is allowing that economic moment for them to occur would bleed off. And if it bled off, then it wouldn't break the shale, then the gas wouldn't come out. Maybe a little further in the illustration. Companies have been drilling in through the Marcellus for a long time in parts of Pennsylvania. And when they do, they get what they refer to as a gas show. They'll see some gas that will be measured in hours of time, And in some cases, there's been some reported in days worth of time. They get a big surge of it, but for a very, very short period of time. So essentially it has no economical value. By the hydraulic fracturing process that they go through, and explaining a little further why they do it, then they get gas shows that last, or the expected life of these wells is measured in decades worth of time. So it went from hours worth of time to decades worth of time. That's the reason why the hydraulic fracturing process, combined with the horizontal drilling, is now being deployed in gas shales, and in particular we think about the Marcellus. So the question then is, can those fluids migrate from depth? And that's, again, when you hear so much in the media about the fracking side, where the concern is that those chemicals might do it. There's a DOE report, Department of Energy report, that just came out recently. We follow the story very closely. You'll see one of the things they talked about was acquiring more micro-seismic data. And what companies do is they'll actually put down into some of the well bores nearby, and they can monitor this either from the surface or down in the well bores, a variety of technologies and techniques that are still evolving in the process. And they can determine just exactly how far out that frac is extending, how far up it extends, how far down it extends, how far on a lateral basis. So it's kind of a radial fashion or a squashed radius that actually occurs when that fracking process actually happens at depth. You're able to track that and see just how far that process goes. This is some of that data from one of the companies out there, and it's showing this is on a depth basis. And the other thing, these blue lines across the top, is actually looking at the bottom of the potable groundwater. So again, it shows you what the depth difference or the distance is between the groundwater zone, the potable groundwater, and where the frac is actually extending out to. So what it shows you is there's a great distance in between the two. When you combine that with physics that are involved there, when you combine that with pressures that are involved, you would see very quickly that's why we're not seeing migration of those fluids from there to the surface. So we're not seeing groundwater contamination from the fracking process occurring, and it's not likely or it's not probable to occur for those reasons.